Breaking news from the cosmic shore, the newest image of Andromeda reveals secrets of galactic violence. Today, astronomers have released a breathtaking new composite image of our nearest galactic neighbor. This isn't just another pretty picture, it's a time machine, a crime scene, and a crystal ball all at once. By combining data from multiple telescopes, scientists have peeled back Andromeda's layers, exposing scars of ancient collisions and vibrant nurseries where billions of new stars are being born. The universe is not a quiet place. It's a dynamic arena of creation and destruction. What you're seeing is a story, one of the grandest epics we can witness from our small perch in the Milky Way. This new view provides unprecedented detail, revealing individual star-forming regions and faint streams of stars left behind by galaxies Andromeda devoured. These stellar ghosts tell a tale of galactic cannibalism, a process that shapes massive galaxies like Andromeda and our own. For centuries, Andromeda was just a faint patch in the night sky. Now it stands revealed as a complex, living system. This image is the culmination of decades of technological advancement and human curiosity. We can now map the galaxy's structure in 3 dimensions and piece together its dramatic history. We are no longer just looking at Andromeda, we are exploring it, almost as if our spaceships were already there. Understanding Andromeda is fundamental to understanding our own galaxy, the Milky Way. By studying Andromeda's past and evolution, we gain invaluable insights into the forces that shaped our own stellar home. Every discovery about Andromeda holds up a mirror to ourselves, reflecting our past and illuminating our future. So, let's embark on this journey together. Let's venture across the 2.5 million light-years and explore the mind-blowing revelations of our magnificent neighbor. What exactly is Andromeda? In simple terms, it's a spiral galaxy, much like our own Milky Way, but that description barely scratches the surface. Imagine a vast spinning city of stars, gas, and dust, bound by gravity. Andromeda, also known as Messier 31, is the closest major galaxy to us, and the most distant object visible to the naked eye. That faint smudge in the autumn sky is actually a sprawling metropolis of 1 trillion suns. Andromeda is about 2.5 million light-years away. The light you see tonight began its journey when early humans first walked the Earth. Every time we gaze at Andromeda, we're looking into the deep past, a cosmic time capsule. Andromeda is immense. Its disk stretches over 220,000 light-years across, and it contains around 1 trillion stars. If you could count 1 star per second, it would take over 31,000 years to count them all. Placed in the night sky, Andromeda would appear 6 times wider than the full moon. It's our cosmic twin, but bigger and more massive, a unique opportunity to study a galaxy like our own from the outside. Living inside the Milky Way makes it hard to map our own galaxy's structure. But with Andromeda, we have a clear, external perspective. We can see its majestic spiral arms, brilliant central bulge, and sprawling halo all at once. Andromeda is the perfect laboratory for understanding how large spiral galaxies work. It's our window into the workings of the universe. Andromeda's trillion stars, each one a sun, many with their own potential solar systems. Imagine our solar system, then multiply that by 1 trillion. The odds are staggering. Countless worlds, perhaps even life, orbit those stars. Andromeda isn't just a collection of stars. It's 1 trillion chances for cosmic wonder. The galaxy's core is a dense sphere of ancient stars, packed thousands of times more tightly than in our own neighborhood. If you lived near Andromeda's core, your night sky would be ablaze. No true darkness, just perpetual twilight. But such intensity might make it a harsh place for life as we know it. The latest images help us appreciate Andromeda on a new level. We're beginning to resolve its constituent parts. The Hubble Space Telescope's PAT program has cataloged over 100 million individual stars. We can now distinguish between young, hot stars in the spiral arms and older, cooler stars in the bulge and halo. Each star is a data point, a clue to the galaxy's life story. We're moving beyond seeing Andromeda as a single entity. We're reconstructing its history, star by star. This is the power of modern astronomy. Andromeda is a city of 1 trillion suns, each with its own story. Our understanding of Andromeda was built over centuries. For most of history, it was just a little cloud in the constellation Andromeda, first recorded by Persian astronomer Abd al-Rahman al-Sufi in 964. With the invention of the telescope, astronomers like Simon Marius and Charles Messier observed it, but its true nature remained a mystery. Most thought it was a nebula within our own galaxy. The debate over these spiral nebulae culminated in the Great Debate of 1920, were they nearby gas clouds or distant island universes? Edwin Hubble settled the question in 1923, using the Hooker telescope to resolve individual stars in Andromeda. He identified Cepheid variable stars whose brightness allowed him to calculate their distance. The result? Andromeda was far outside the Milky Way. Our universe suddenly became much, much bigger. Hubble's discovery was revolutionary. Andromeda wasn't a nebula in our galaxy, but a separate galaxy millions of light years away. The known universe expanded overnight. We were no longer the center. The Milky Way was just one galaxy among countless others. Hubble and others soon found Cepheids in more spiral nebulae, proving the universe was filled with galaxies. This was the birth of modern extragalactic astronomy. Hubble also noticed that most galaxies' light was redshifted. The farther away, the faster they moved from us. This was the first direct evidence that the universe is expanding. If the universe is expanding, it must have had a beginning, the foundation for the Big Bang theory. The study of Andromeda didn't just reveal other galaxies, it led to the discovery of the expanding universe and our cosmic origins. Our understanding of space, time, and existence was forever changed. All thanks to a careful study of our nearest galactic neighbor. Andromeda opened the door to the cosmos. Andromeda bears the scars of a violent history. Galaxies grow by colliding with and consuming their neighbors. The latest images reveal vast, faint streams and shells of stars, remnants of smaller galaxies torn apart by Andromeda's gravity. These tidal streams are cosmic ghosts, tracing the orbits of devoured galaxies. The giant stellar stream is a prime example, a remnant of a major merger that triggered bursts of star formation. Andromeda's growth was shaped by these cataclysmic events. Our own Milky Way has similar streams, evidence of its own cannibalistic past. By comparing Andromeda and the Milky Way, we refine our models of galaxy evolution. Studying Andromeda's scars helps us understand how galaxies are built. To truly understand Andromeda, astronomers launched massive surveys like FAT and FAST using the Hubble Space Telescope to scan huge swathes of the galaxy. The PAT survey alone resolved over 100 million individual stars, creating a detailed demographic map. By observing in multiple wavelengths, astronomers can determine the age, mass, and composition of these stars. High-resolution images have revealed Andromeda's structure in astonishing detail. One surprise: a vast, rotating plane of satellite dwarf galaxies orbiting Andromeda, challenging standard cosmological models. Within Andromeda's disk, astronomers found clumpy rings of dust and young stars, not the smooth spirals we imagined. A massive elliptical ring of star formation may have been created by a head-on collision with a smaller galaxy. These discoveries show Andromeda is a dynamic, evolving system. Each new survey uncovers more complexity. The more we look, the more we find. Andromeda's story is tied to our future. Unlike most galaxies, Andromeda is hurtling toward us at 110 kilometers per second. Thanks to precise measurements, we know a head-on collision is inevitable, beginning in about 4.5 billion years. This won't be an explosive crash. The vast distances between stars mean direct collisions are rare. Instead, the two galaxies will merge in a slow, majestic dance, flinging stars and gas into space and triggering bursts of star formation. After several passes, the Milky Way and Andromeda will settle into a single, larger galaxy, likely a giant elliptical. Our sun and planets will probably survive, but their orbits will change. The night sky for our distant descendants will be utterly transformed. This grand cosmic union is our shared destiny. The story of Andromeda is also the story of the Milky Way. We are on a collision course with our cosmic sibling. The universe is always changing, and we are part of that change. Despite all we've learned, Andromeda remains a place of mystery. Every discovery opens new questions. What galaxies did it devour? Can we map its entire violent history? Its central supermassive black hole is more massive than ours, and evidence hints at a strange offset nucleus. Perhaps even two black holes orbiting each other. Future telescopes like the James Webb will probe these mysteries. Andromeda's trillion stars mean a trillion chances for life. Are there civilizations there, looking back at us? Studying Andromeda helps us understand our own place in the universe. It's a mirror, a crystal ball, and a cosmic neighbor. The next time you see that faint smudge in the sky, remember, you're seeing a story, a mystery, and a future. The cosmos is waiting.